Hello everyone, welcome to another Voiceflow tutorial. In this set of tutorials, we will be discussing how to create a RAG system, which stands for Retrieval-Augmented Generation system. So what is the reason, why do we need to build these types of architectures, this RAG architecture? Why do we need it? So think about it this way. For those who don't know, right, if you ask ChatGPT questions, it's able to give you a response, right? Same with Gemini, same with Llama, right? So all the popular AI platforms are able to do this for us. And the reference point for these LLMs, or where they get their data from, is the internet, majorly. Now, what if the information that you're trying to get from your LLM is not on the internet? An example of these types of data can be internal HR policies of your organization, right? It could be internal employee records. It could be patient records, right, in a hospital. It makes it limits, obviously, is a limitation of what these powerful AI platforms can do, right? So one of the workarounds is building a RAG architecture, especially if you want to leverage the power of AI within your organization, right? Leveraging your organization's data with AI. So usually you will find a lot of RAG architectures out there. So that is the reason why we use RAG, or we try to build RAG architecture. So this is how the whole RAG architecture is set up, right? So this is like a bare bones explanation, a simplistic one, so that everyone can follow along, right? So we start with the first process. So the first process is we have our internal documents. Let's assume they're PDF files. Now these PDF files, I didn't show this here, but they are chunked, right? They are broken down into smaller chunks, right? So one of the things you could probably have asked is, okay, why do we even have to use the RAG architecture? Couldn't we just pass in our PDF file the way we can right now on ChatGPT, and then just ask questions based off of what is in the PDF file, and ChatGPT should be able to respond to us? That is a good idea, right? But then it has its limitations, right? Because these LLMs, these large language models, have limitations to their context windows, right? So you cannot just put, like, especially if your PDF file is like a few hundred pages long, right? You cannot put that many words into the LLM and expect it to still perform optimally. It might even tell you that, okay, you've blown the context window, right? There's basically too much text within what you've sent to it, right? So the RAG architecture helps you manage that aspect as well, right? So you're not overloading the LLM with text. So basically, back to what I was explaining about this process, these files here are chunked, so right, they are broken down into smaller chunks, and each of those smaller chunks are then converted into vector embeddings, right? So now these vector embeddings are basically numerical representation of text, right? So the numerical representation of text, that is the vector embeddings, they encapsulate semantic meaning, right, within those texts. right? So it means that, okay, so if we have like a word like a sentence like I am a boy and I am a man or something, right? You would expect that their embeddings will be sort of similar, right? So they'll be semantically similar to each other, right? Basically. And so when we do something called a similarity search between those two sentences, right? So we've let's say this is the embedding for I am a boy and this is the embedding for I am a man. We run a similarity search or a similarity mathematical algorithm, right, between both vectors, right? We should get like a percentage of how, it's not necessarily a percentage, but a percentage of how similar both embeddings are, and that percentage of how similar both embeddings are maps directly to how similar both sentences will be as well. So in essence, the idea of creating these embeddings is so that whenever we want to maybe search for something within these PDF files, right, we can just simply whatever it is we are searching for, we convert that to a vector embedding, and then after that a similarity search is run against the embeddings, right, within the vector embedding chunks that we have, and then the correct chunk of PDF or chunk of text is then returned, right? I already explained the entire process for process 2, but I just wanted to give you some context, right, as to why we're doing this. So anyways, we have our PDF files, they are chunked, and those chunks are given vector embeddings, right? And those vector embeddings are then stored in something known as a vector database. Two examples, popular examples of vector databases: Pinecone, right? That's PINECONE, and then Weaviate, right? WEAVIATE. Okay, so at the same time, these embeddings, right, are also stored. Other than these embeddings, right, the text, right, the chunk of text are also stored on the database, so that we're able to know, okay, this embedding maps to this text, this embedding maps to a different text, this embedding maps to a third text, and so on and so forth. So that's how this entire process is created, right, in a nutshell, right? So we now have our data chunked within the vector database. Now for the process 2, which is basically how we would use a RAG architecture, right? So let's say a user sends in a query or a question. Now that question is converted into an embedding, right? Just like all these are chunks are converted into embeddings, the question will be converted to an embedding. Now the embedding now will run a similarity search on the embeddings within the vector database, right? So all the embeddings within the vector database that have let's say a high similarity score, right, they're the ones whose text will be returned, right? So once that text has been returned, right, we can then send it to an LLM, right? So this could be OpenAI's API, Gemini, Llama, Claude, anyone you want, right? Now after this, your LLM can then take the question that you initially posed and then compare it with the chunk that has been retrieved, and then give you a relevant answer to your question, right? So that is basically how the whole RAG architecture works. Now we're going to be building this in Voiceflow. Now trust me, without Voiceflow or without like no code capabilities of Voiceflow, this would have taken a while to build, right? And well, with Voiceflow, it's just a few steps, right? And that's one of the powerful things about Voiceflow. So we're able to build a RAG architecture and start using it right away within Voiceflow, and I will show you that in the next video. For now, I believe we have touched upon all we need to touch upon. Thank you very much for watching. I'll see you in the next one.